Welcome to the Maersk Developer, the first in a series of 3 ultra-deepwater semi-submersibles delivered to Maersk Drilling between 2009 and 2010. The state-of-the-art design of the rigs was made in collaboration between Maersk Drilling, Keppel FELS and Marine Structure Consultants, based on input from customers and service providers to oil companies. The rigs are designed to operate in moderate metocean conditions, in water depths of up to 10,000 feet, and they are capable of drilling to a depth of 30,000 feet. They have been designed to drill and complete deep water wells and install subsea facilities with optimum efficiency. The rigs are dynamically positioned semi-submersible with 8 4-megawatt thrusters and have a transit speed of 7 knots. They also have 8 anchor winches for use with a pre-laid mooring system. With a displacement of 53,000 metric tons at drilling draft and a variable deck load of 7,000 metric tons, the rigs have large storage capacities for the operator's consumables and also provide dedicated and optimized extensive deck space and layout for the operator's equipment. The design has been developed to deliver a safe, efficient and innovative high-end drilling tool to the industry. Maersk Drilling believes that the way to increase efficiency and safety is to increase the mechanization of the drilling process. Essential to this process is the selection and hiring of the correct personnel to operate the equipment. The senior crews for these rigs are involved 18 months in advance of the rig going to work in order to go through a vigorous training and familiarization process. Let us look at this rig in more detail. The central control room, or bridge, is located on top of the accommodation block. Dynamic positioning, ballast control and principal alarm monitoring is conducted from here. Ample office space and conference facilities on the upper deck is available for the rig crew, the client's representatives, and third-party service companies. Accommodation is provided for 180 personnel, consisting of 10 single and 85 two-berth cabins. The 5 decks provide all the facilities you would expect of a floating hotel, including 270 square meters of recreational space. We'll now move our attention to the features for enhanced efficiency, starting out with the drill floor and tubular handling systems. Within the derrick, there are 2 hoisting systems, the main and the auxiliary. The mainline activity takes place on the right-hand side and the offline activity on the left-hand side. The derrick itself is rated to 3 million pounds combined load. The main hoisting system is outfitted with a 2 million pound capacity, while the auxiliary is rated to 1.5 million pounds. We have designed the rig to be able to achieve dual handling activities. As seen here, this means that, for instance, while tripping with the main system, casing for the next step of the operation can be made up and racked back in the low setback area by the crew working with the auxiliary. Tripping drill pipe on the main well center requires no crew member contact with any of the moving machinery. The 2 vertical pipe rackers, which allow the concurrent activities, are controlled from the driller's control room by 2 drillers and their assistants. The senior team works the main system, which is on the right, as we are now looking at the drill floor. The tubular setback area is outside the derrick and drill floor on the cellar deck, which provides a greater pipe setback capacity and a lower center of gravity. There is in excess of 50,000 feet setback capacity for drill pipe, and we can rack from 16-inch casing to 7-inch liner with capacity for 15,000 feet or 7-inch liner. Here we can see the pipe being delivered from its storage area at the aft of the drill floor. It is a safe and efficient system, controlled and monitored by the assistant driller by means of a CCTV system while the driller is running the pipe into the well. The casing has been made up and racked on the port-off side of the drill floor, ready to be run in stands of 3 joints, saving make-up time when it is to be run into the well. The 2 drill crews are going to be constantly active, as are the maintenance crews, who will be following Maersk Drilling's preventative maintenance systems, thus ensuring the equipment is always ready to deliver high performance. The mud system has been designed to allow mixing and handling of 2 fluids simultaneously. This will reduce the time taken to change from water-based mud to oil-based mud, for example. The solids control system consists of 8 shale shakers, split into 2 banks of 4. We are able to install cuttings dryers and centrifuges for zero-discharge operations when required, and as mentioned before, there is ample deck space and storage capacity for any combination of cuttings handling and disposal. We have a fluid surface capacity of 1,500 cubic meters, amongst the largest of any semi-submersible. 4 2200 horsepower mud pumps rated to 7,500 psi are provided for optimum hydraulics and to minimize downtime. There are storage tanks in the pontoon for weighted liquid mud, brine, base oil and fuel oil. Large capacity for bulk material is also provided in the columns for a total of 1,360 cubic meters. The 18 3/4 inch 15,000 psi BOP has 2 annulars and 6 ram preventers. The lower ram can be configured as a test ram. The unit has a multiplex control system with redundancy to allow both pods to operate with 1 fiber optic cable. The riser is stored vertically forward of the drill floor, and we're able to store 9,600 feet. We see the riser handling crane delivering the 75-foot clip riser joints to the drill floor handling system, where a double is being prepared to be connected to the BOP. Here we can see the riser running tool being remotely made up to the riser joint. The riser guidance arm centralizes the riser joint over the riser spider. Here we are looking at the moon pool area. This large moon pool also gives the flexibility for multiple activities. The BOP carrier moves to well center. The riser is lowered onto and connected to the BOP. The underhull guides are used to secure the BOP before it is run into the water. Final checks are made prior to running the BOP and riser into the water. The riser is made up with clip connectors. From stab to makeup of the connector takes 12 seconds. This represents a considerable time saving in comparison to other marine riser connectors available in the market. The riser string has now been run and the riser gas handler is now installed. This tool will allow the riser above the BOP rams to be circulated to the choke manifold and mud gas separator in the event of a well influx reaching above the BOP. The slip joint is equipped with a remote-operated pull-in system that greatly enhances the safe and efficient handling of the kill and choke hoses and mud boost lines. Work baskets installed in the moon pool area and capable of traversing the length of the moon pool assist with the safe operations over water, significantly reducing the requirement for man-riding winch operations. The 4.2 million pound N-line riser tensioner system is secured to the riser string. This system has a 2 million pound trip saver feature, which allows a wet parking position for the BOP and riser string if required. The portside crane is a heave-compensated crane with a capacity of 165 metric tons when used for cargo handling. The crane is rated to 100 metric tons in a 10,000 feet water depth. The knuckle boom crane situated at the aft of the rig is used to supply tubulars and equipment to the upper pipe deck and elevated catwalk area. A large number of the lifts can be accomplished without assistance from the deck crew, thus greatly enhancing the safety. The starboard crane is a conventional deck crane, which is also able to work on the BOP when the BOP is stored on deck. It has a 165-foot boom length, a 60-ton rating at minimum radius on the main block, and 15-ton rating on the whip line. We have simulated loading the rig for typical well situations and for envisaged situations. As illustrated, we can see the rig loading up with some completion equipment. On the port side of the rig, we can accommodate multiple subsea trees and accessories, which can be easily brought on board the rig using the subsea crane. As this rig has been designed for multiple subsea developments, the large staging area is matched with a large capacity in the moon pool for handling subsea trees and accessories. Subsea equipment can be deployed to the seabed using the main well center and the subsea crane. The subsea trees and equipment are moved from the staging area into the moon pool. Equipment can then be stacked up on the tree cart. The cart has 230 metric ton capacity and large vertical clearances to handle vertical or horizontal subsea tree systems. Additional space and clearance are provided for deployment of external control systems and other circulating lines. Whilst most of the work can be carried out within the handrails, work baskets aid the safe operations in this area. There is 17 meters of available build height from the tree carrier to the underside of the overhead crane. With the available build height and carrier capacity for tree, LRP and EDP can be stacked up and tested prior to deployment. Once the tree has been built using the bridge crane in the moon pool, it can be moved to drill center in preparation for deployment. The casing sleeve is lifted to allow this. A number of external electrical, hydraulic and/or control lines may be attached to the production tubing and tubing hanger running tool, or the subsurface test tree. We will use the deck above the main drawworks to provide space for the full range of the related equipment. The production riser is now attached. The moon pool trolley is retracted and the subsea tree is run from the main well center. Subsea completions involve a substantial amount of additional equipment and services, including completion fluids, well test equipment, stimulation, wireline, coil tubing, downhole tubing and accessories. The large usable deck space on the rig provides the capability to load all of these items on board. After consultation, special attention has been given to third-party equipment and services. Specific areas of deck have been identified for particular placement of equipment. For example, the selected location of the coil tubing unit has been deck strengthened to support the largest coil tubing unit available in the market. Modeling has been carried out to ensure that clashing is avoided when entering wireline or coil tubing to the rig floor. The heave-compensating crane allows an additional capability for deploying subsea equipment to the seabed. This unique feature will improve efficiency for multiple well developments. Because of the complexity of subsea completion operations, 2 ROVs are often used. The main work-class ROV is within the structure of the rig with its own moon pool. When installed, a second work-class ROV can be deployed from the aft end of the rig. Guided launching systems are provided for each ROV to allow deployment and recovery in high currents and heavy sea states. We believe that we have designed a rig to optimize deep water drilling and development activities. Thank you for allowing us the opportunity to present Maersk Drilling's new ultra-deep water development semi-submersibles.